champions, welcome to the first chemistry video of Sankalp KCET 2026 series. Now this series is going to be your one-stop solution for getting a top rank in KCET 2026. Now that is because we are going to cover all the subjects, physics, chemistry, maths and bio, and we are going to solve a lot of previous year questions and other questions as well that will help you to get a top rank. Now, as we are starting a new journey, and the first step in this journey is to build a strong foundation. Before diving into class 12 chemistry, there are certain concepts of class 11 which keep showing up again and again. For example, mole concept, equilibrium, redox reactions, chemical bonding, which students either tend to forget or they haven't understood them well in class 11. So that's exactly why this first video is designed as bridge course, where we are going to discuss all the major concepts of class 11 so that you can enter class 12 without any doubts or without any confusion. Right? So this bridge course is in two parts. Part 1 will be covering physical and inorganic, and in part 2 we'll be doing organic chemistry. I hope that is clear. So let's start this new journey with clarity, confidence and a solid foundation. So yes, part 1, as I already said, we will have physical and inorganic, and part 2 we will have organic. Okay. Now here, yes, as I told you, this is going to be a one-stop solution. You do not have to trust me blindly. Our results have proved it again and again, as well as in 2025. So these are the students who have studied from us from the YouTube. Last year we have also have the series, we have done a 1-year program almost. So these students have continuously studied with us and have got these top ranks. You can see here Prajwal S with rank 171. Then we have Kiran Kumar 443, Deeksha C 693, you have Samiksha 752, Sachin 934, and we also have other students, you can see the list, who have got a very good rank and now they are going to be in the top colleges of Karnataka. Now if you want that you should also be the next person in this slide, you also want to be a top 1000 rank or a very good top rank in KCET 2026, then quickly subscribe the channel and follow the video every day so that you can get all your concepts clear, and then you can also get a proper understanding of the chapter and can top your KCET 2026 examination. Also, you can join our WhatsApp channel. The link is there in the description section. All the PDF and everything will be available in our WhatsApp channel. So please do not forget to join the WhatsApp channel. So waiting to see all of you in the next year in this position. So yes, let's start this journey with this positive note. Okay, so as I told you, we will have physical as well as inorganic in this video. So first thing is physical chemistry. Here what all concepts we should be knowing or will be talking about. Let's have a list of that first. So we will be talking about mole concept. Whether you have understood this or not, I don't know, but mole concept is something which is very, very important in physical as well as in organic chemistry. It is almost the, I can say, the stepping stone of chemistry. You should be very, very clear with this particular concept. Next we have concentration terms. Next we'll be talking about redox reactions, oxidation numbers as well as logarithms and graph. Okay, so this is something maybe new for you, but yeah, this is required in, I think one chapter is there you will be requiring this one. So that is why we will be talking about these things also. Okay, now first coming to mole concept, very basic definition I want you all people to know is the definition of 1 mole. 1 mole tells you what? It is a unit of what? Amount of substance. It is a way of telling how much quantity of the substance is present, right? It is a way to quantify the substance, or it is a way to tell how much matter is present. Now 1 mole means, you should remember this magic number 6.022 into 10 to the power of 23. Okay, so if I tell you 1 mole of pen, it is 6, that means 6.022 into 10 to the power of 23 pence. If I tell you 1 mole of dairy milk chocolates, that means it is 6.022 into 10 to the power of 23 dairy milk chocolates, right? So now if you see here, 1 mole of copper means we have, this is just a minute. Yeah, suppose I have 1 mole of carbon here whose mass is 12 gram. So this is 1 mole of carbon, that means I have 6.022 into 10 to the power of 23 carbon, and if I have 1 mole of copper, I have also 6.022 into 10 to the power of 23 copper atoms. Okay, but their masses are different. See, 1 mole of carbon mass is 12 gram, whereas 1 mole of copper mass is 63.5 gram. Okay, so now let's understand it. What is molar mass? Molar mass, next term that I need all of you to understand is molar mass. Now molar mass is the mass of 1 mole of substance. Mass of 1 mole of a substance. Now see, let me give you an example. If you have 1 dozen, you know all of you 1 dozen means 12, right? If you have 1 dozen of pencils and you have 1 dozen of bricks, okay, so that means 1 dozen of pencil means you have 12 pencils, 1 dozen of bricks means you have 12 bricks, but will their masses be equal? No, right? Bricks masses will be more, pencil masses will be less. Similarly, 1 mole of carbon and 1 mole of copper will have same number of atoms, because 1 mole means 6.022 into 10 to the power of 23. So 1 mole of carbon will have 6.022 into 10 to the power of 23 atoms. 1 mole of copper will also have 6.022 into 10 to the power of 23 atoms, but their masses will be different. So whatever is the mass of that 1 mole of carbon, or I can say the mass of 6.022 into 10 to the power of 23 carbon atoms is your molar mass. Okay, so how can I write it? I can write it like this: mass of 1 mole or mass of 6.022 into 10 to the power of 23 carbon atoms, right? This is mass of 1 mole and that is equal to this much. Carbon atom is 12 grams. Okay, now you have also copper, mass of 1 mole, okay, or mass of 6.022 into 10 to the power of 23 copper atom is 63.5 gram. Okay, so are you getting this one? 1 mole, that mass is whatever, this 63.5 gram is the molar mass of copper. Similarly, this 12 gram is the molar mass of carbon, right? Okay. Now, if this is clear, one more thing I want to mention, speciality about this particular number. This is called as your Avogadro number. Okay, and it is represented with N and a subscript A. Okay, Avogadro number means this value. Okay, fine. Now, we have something called conversion. Okay, so you can convert. Now see, we have 3 things. I have moles, okay, I have number of particles and I have grams. So if you want to convert number of moles to number of particles, then you have to simply multiply with Avogadro number. Okay, so just a minute. Yeah, you have to multiply with Avogadro number. If you have number of molecules and you want to convert it to number of moles, then you have to divide by Avogadro number. Now let me just give you an example here. Suppose I tell you that I have 1 mole of, suppose I tell you that I have 1 mole, not 1 mole, let me make it 3 moles. Okay, I have 3 moles of carbon atoms. Then the question is, how many number of atoms I have? I have 3 moles. Okay, so just imagine if I tell you I have 3 dozen of carbon atoms, that means how many carbon atoms are there? 1 dozen means 12, 3 dozen means 12 into 3, 36 carbon atoms are there. But if I tell you 3 moles of carbon atoms, so we know that 1 mole is how much? 1 mole is 6 into, I can just write down 6.022. See, 1 mole is 6.022 into 10 to the power of 23, and 3 moles will be, I can just multiply here, 18.06 into 10 to the power of 23 carbon atoms. Now if I ask you that these many atoms are there, how many moles will be there? Then you just have to divide 18.066 divided by 6.022, that will give you 3 moles, right? We have done with this one. Now coming to mass. If you have been given with moles and you want to convert it into mass. So I know that, see, 1 mole of carbon is 12 grams. If I want 4 moles of carbon, what is its mass? It will be 48 grams, right? Similarly, if I have 1 mole of copper, it is 63.5 grams. If I give you 4 moles of copper, how will you do? So if you have been given with moles and you want to calculate the mass, if you have been given with moles and you want to calculate with mass, then what you have to do? You have to multiply 63.5 into 4, right? Fine. Now here there is one, this is not there. This is the thing that you should be knowing. If you have number of moles, you want to convert it into number of molecules, multiply with Avogadro number. Or if you have number of molecules or atoms or ions, anything, and you want to convert it into number of moles, divide by Avogadro number. If you have number of moles, you want to convert it into mass, then multiply with molar mass. If you have mass and you want to convert it into number of moles, then divide by molar mass. Okay. Now if mass is there, number of moles is asked, then you have to go through number of moles. Now let us do some examples here. Suppose I tell you that I have, suppose I tell you that I have 160 grams of NaOH. Okay, this is mass is given. What is the number of molecules of NaOH? Okay, so you remember, you have to remember this one. So let me just draw that one. Okay, suppose here I have moles. Okay, here I have mass. Okay, and here I have number of particles. Okay, now how to convert, I have already discussed, but yes, once more we'll talk. Moles to number of particles, you have to multiply with Avogadro number. Mass to moles, number of particles to moles, you have to divide by Avogadro number. Moles to mass, multiply with molar mass. Mass to moles, divide by molar mass. Okay, now in this question what is given? Mass is given to you. What is the mass given to me? Mass given to me is 160 grams. And then what is asked? Number of molecules, number of particles or number of molecules is asked. So to go from here to here, there is no direct way. What you have to do? First you have to convert mass to moles, then you have to convert moles to number of particles, right? So mass to moles, how to convert? Divide by, mass to moles. Okay, just a minute, here I did a mistake. Just a minute. Yes, moles to mass you have to moles to mass you have to multiply with molar mass. Mass to moles, divide by molecular mass. Okay, so now we have 160 gram mass, we have to convert it into moles. So we will divide by the molar mass. So let's calculate the molar mass of NaOH. Okay, so here I'll tell you how to calculate the molar mass as well. So let's calculate molar mass of NaOH. Okay, now sodium mass is 23, oxygen mass is 16, and hydrogen mass is 1. So if I add them all, I'll get 40 grams. Okay, when you write molar mass, it is 40 grams per mole. Now I have molar mass is 40, mass is 160. So what is the number of moles? Number of moles I will get here is, see, mass divided by molar mass, mass is 160, molar mass is 40, you will get 4 moles. Okay, so now how many moles I have? This 160 gram is equal to 4 moles, right? Now you know 1 mole contains 6.022 into 10 to the power of 23 atoms. So 4 moles will contain 4 into Avogadro number. So what is the number of particles or number of molecules of NaOH? 4 into 6.022 into 10 to the power of 23. 3. Okay, so that will give me how much? 4 2s are 8, 8, 24 into 10 to the power of 23 molecules of NaOH. Right, this is clear. This is the conversion of mass to particles. Mass to moles we can do directly, moles to particles we can do directly, but mass to particles or number of molecules we have to go by converting it into number of moles first. Okay, good. Now let's move forward here. Yeah, now we'll go to the next topic, that is your concentration terms. Now what do you mean by concentration terms? Concentration terms help us to tell about how much solute is present in a solution. Okay, solute, solvent, I hope all of you know that when you dissolve, when you prepare a solution, we need to talk about this concentration. Now there are three important terms in concentration. One is mole fraction, one is molarity, and one is molality. So now first let me tell you about mole fraction. So suppose I have mixture of A and B. Okay, in this container you have some particles of A and some particles of B. So what is the mole fraction of A? Mole fraction of A will be number of moles of A. Okay, Na is what? Just write down this one. Na is number of moles of A divided by number of moles of A plus number of moles of B. Now similarly, what is mole fraction of B? It is number of moles of B divided by number of moles of B plus number of moles of A. Now these two, what is the relation? This is very important. XA plus XB is equal to 1. Okay, chi, we tell it as chi or X. Okay, this is the concept of mole fraction. Next, molality. What is molality? This is very important. Molality is number of solute per, sorry, not number of solute, number of moles of solute. You can write it in that way. Number of moles of solute per kg of solvent. Number of moles of solute per kg of solvent. Okay, now let me give you an example. Now first of all, molarity, right? Okay, here again I made a mistake. Number of moles of solute per liter of solution. Okay, so I'll tell you number of moles of solute per liter of solution. Okay, I'll explain you it in much more detail, but let me just tell you molarity is denoted with capital M. Okay, so capital M, number of moles of solute, number of moles is denoted by N, divided by volume of the solution in liter. The volume of the solution should be in liter. Next, if the question is there, the volume is in milliliter, then what I will do? I'll convert this liter to milliliter, right? So we have to volume, if the volume is given in milliliter, then you have to multiply 1000 here, right? Now what else I can modify? This number of moles, suppose directly number of moles is not given, mass is given to you, then how will you do? So it is, see, WBMB. This is what? Mass of solute. Okay, MB is what? Molar mass of solute. Okay, so here I will write mass WB by MB into 1000 by volume of the solution. Whether liter or ml, you have to check here. Okay, now just let me explain it in much more detail. Suppose, what is this molarity? Let's understand. Suppose I have 8 moles, okay, 8 moles of any solute, and this contains a solvent. Okay, this contains a solvent and this solvent is 4 liter. Okay, so how can I just divide it? So 4 liter means, suppose it is like this. Okay, so I can say this is 1 liter, this is 1 liter, this is 1 liter, and this is 1 liter. Okay, Now number of moles is total 8 moles. It is divided in this 4 liter. So here it will be 2 moles. Here it will be 2 moles. Here it will be 2 moles. And here it will be 2 moles. Means suppose in 4 liter there are 8 moles. But when we talk about molarity, we talk about in 1 liter how many moles are there. In 1 liter there will be 2. So if you just calculate molarity formula, number of moles is 8, volume of the solution in liter. So it is already in liter, so no need to multiply 1000, I will get 2. And molarity is designated as 2m. Now this tells us that there will be 2 moles of solute in 1 liter of the solution. Okay. So whenever for any solution, if I tell you there is a solution whose concentration is 0.005 molar. Now what does that mean? That means it has 0.005 moles, or let it be of NaCl solution. Okay. So 0.005 moles of NaCl solute in 1 liter of solution. Right? This is the meaning of molarity. Okay, this meaning is very, very important. You should be able to derive this information from the question given. Okay, now let's move forward to the next thing, that is molality. I'll be discussing that. So here I have already given you mole fraction. We have given this formula as well. Okay, so this is actually XA. Okay, so here's a question from mole fraction. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2. Now this is, let's try to solve this question. So you have a solution where 20% is C2H6O2, right? So I can say that if 20% means 20 gram is C2H6O2. Okay. Next I have, then what is this 80 gram? Because see, whenever it is percentage, that means total mass is 100 gram. Out of that 20 is C2H6O2. Then 80 gram, you have to consider it as water. Okay. So let this be A, this be B. Okay. So first let us calculate the number of moles of A. Okay. Number of moles of A will be what? Given mass by molar mass 20 by this mass. So 12 twos are, so let me just calculate molar mass of A, that is 12 twos are 24 plus 6 plus 16 twos are 32. Okay. So 24 plus 6 30, 30 plus 32 is 62. Okay. So here it will be 20 by 62. Now number of moles of B will be how much? 80 by 18. Okay, given mass, molar mass of water, I think all of you will be able to calculate. 2 plus oxygen is 16. Each hydrogen is 1, 1 plus 1 is 2, 2 plus 16 is 18. Okay, so that is why 80 by 18. Now what is the formula? To calculate the molar mass of ethylene glycol, XA will be equal to NA by NA plus NB. So that will be equal to 20 by 62 divided by 20 by 62 plus 80 by 18. Okay. Now if this we divide, okay, we will be getting answer around 0.068. Okay, so you can solve this, you will get 0.068 as the mole fraction of ethylene glycol. Okay. Okay, next we'll go to molarity. So molarity, I have already discussed the formula. Now here's the question. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of the solution. Very direct question. What is the formula of molarity? Given mass of the solute by molar mass of the solute into 1000 by volume in ml. Okay, so WB is 5 gram. MB is how much? NaOH mass is 40 into 1000 by what is the volume here? 450. Okay, we can cancel this one. Then we have 2 2s are, 2 5s are, then I have 5 1s are, 5 15, 5 9s are, right? So I have 5 by 18. Just if I have done the calculation correct, yeah, 2 2s are 2 5s are 5 1s are 5 9s are, so 5 by 18 I will be getting, right? So if I solve this, I will be getting here, so you can see 5 by 40 by 1000 by 450 I took. Yes, so if I solve this, I'll get 0.278 molar. I have done the proper solution. You can check it, do the calculation. This is the answer that you will be getting. Now we'll go to the next concentration term, that is molality. Now molality is moles of solute by mass of the solvent in grams. Okay, in molarity it was volume of the solution, here it is mass of the solvent in gram. If it is gram, you have to multiply 1000. Molality will be equal to mass of the solute by molar mass of the solute into 1000, right, by what mass of the solvent in grams. Okay, if the mass of the solvent is directly in kg, then you don't have to multiply this one, it will be directly by, if it is in kg, no need to multiply 1000. If it is in grams, you have to multiply this 1000. Just multiplication is done to convert this gram to kg. Okay, now here you can understand, for example, if I have this one, yes, so suppose I have 1 mole of KCl. Okay, so if you have 1 molar KCl, okay, that means what? That indicates that we have 1 mole of KCl in 1 kg of the solvent. Okay, now 1 mole of KCl mass is 74.5 gram. I can say 74.5 gram of KCl in 1 kg of solvent. Okay, clear? Fine. Next we will move to, here's a question that you have to calculate the molality of ethanoic acid in 75 gram of benzene. Again a very direct question. What is the molality formula? Given mass by molar mass into 1000 by mass of the solvent. Now what is WB? 2.5. What is the molar mass? CH3COOH. C plus C, carbon 12 plus 12, 24. 24 plus 4 is 28. 28, this one is 32. Okay, so I have 4 plus 4, 8, 9, 10. This is 2. Then I have 3, 2, 5 plus 1, 6. Yeah, so 2.5 by 60 into 1000, right, by WA is 75. Now if I solve this, whatever you get, that is your molality. I have already solved this. You can see here you will get 0.556 molar of the solution. Okay, fine. After this we will have one more question. This is, I'll give you as a homework question, all of you to practice. The solution is there definitely in this video, but I want all of you to try this question. Calculate the molality and mole fraction of Ki if the density, okay, this density is involved, so let me help you here. Okay, next class I'll give you homework. So you have to calculate molality, molarity and mole fraction, all the three of Ki if the density of 20% aqueous solution is this much. Okay, so now see, first of all, this 20% means what? Mass of the Ki, solute is Ki, so I have mass of Ki is 20 grams. Okay, and I have aqueous solution means the rest mass of water. Mass of water will be 80 grams. Okay, next what data I have? I have mass of solution. Since it is 20%, so mass of the solution is 100 grams. And next I have density of the solution. Density of the solution. Density of the solution is 1.202 grams per ml. Now if density, if I know mass and density, right, then can I, what is the formula we have? Density is equal to mass by volume. So if I know density and mass, can I calculate the volume of the solution? Yes. Why I need volume of solution? To calculate molarity. Volume of the solution will be mass by density, which is equal to 100 by 1.2. 1.202. Next, what I need, mass of the solvent. I also need mass of the solvent that I have got, right? So with this, and I need the molar masses of Ki and the molar masses of water. Now I think with all this data we will be able to solve the question. So I have already solved for you. So you can see the first question, we have to calculate here, suppose molality. Okay, so mass of the solute is 20 gram and the molar mass of the solvent is 80 gram because it is percentage given. So here one more thing that I want to tell is the molar mass of Ki is 166. Okay, molar mass of Ki is 166. Now if you see W2 by M2 into 1000 by W1, W2 is what, 20 grams here, M2 is what, 166, 1000 by 80 grams. So that will give you 1.506 molar. Now similarly, if I want to calculate molarity, 20 by 166 into the volume of the solution, if you remember, I have just calculated 100 by 1.202. So that I will substitute here and you will get 1.448 molar here. Now if you know these two are already there, if I want to calculate mole fraction, number of moles of Ki, number of moles of water, mole fraction of Ki will be number of moles of Ki by number of moles of Ki plus number of moles of water, and just substitute all this and then you will get this as the mole fraction of Ki. Okay, just do this question. If you have any doubt, please put down in the comment section. Okay, I'm not taking too much of time in solving this. I have explained this and I hope this will help you. Now moving forward, we'll go to the next topic, that is redox reactions. So in redox reaction, we need to understand the concept about loss of electrons and gain of electrons. See, oxidation means what? Loss of electrons. For example, you have sodium. Okay, when sodium loses one electron, what it will become? It will become Na plus. Plus it will gain, it has lost one electron. So whenever there is loss of electrons, electrons is written on the right hand side. Okay, so that is called oxidation. Loss of electrons is called as oxidation. Next, reduction is what? Gain of electrons. For example, chlorine is there, it has gained one electron, it is called Cl minus, that is called as reduction, gain of electrons. Now the one which is, so this sodium is undergoing what? Sodium is undergoing oxidation. So it will behave in a reaction, if it is undergoing oxidation, it will behave as a reducing agent. The substance which gets oxidized during the redox reaction is behaving as a reducing agent, and the substance which gets reduced in the reaction behaves as an oxidizing agent. Okay, we will clarify this more in the next slide, do not worry. So first of all, what is a redox reaction? We understood what is oxidation, what is reduction. Oxidation is the loss of electrons, reduction is the gain of electrons. Now if in the same reaction, one species is undergoing oxidation and the other species is undergoing reduction, then that reaction is called as redox reaction. Means if in the same reaction, oxidation and reduction are occurring simultaneously, then we call it as a redox reaction. Now let's see an example for here. See, Zn to Zn2 plus, Zn2 plus, it is oxidation, and copper 2 plus to copper is reduction. Now since Zn is undergoing oxidation, it will behave as what? Reducing agent. Just now I told you it will behave as a reducing agent, and copper 2 plus is undergoing reduction, so it is undergoing, or it is behaving as an oxidizing agent. Now question may arise, ma'am, why this is oxidation and why this is reduction? The answer to this lies in the next slide. Okay, so let's see something called as oxidation number. Okay, oxidation number is the charge possessed by the atom in a molecule. It is the charge possessed by the atom in a molecule. Now see, if the oxidation number increases, okay, then it is oxidation, and if the oxidation number decreases, then it is a reduction. Okay, now see, if there is no charge, then the oxidation number is 0. Then Zn to Zn2 plus, what is the change in the oxidation number for Zn? For Zn, the oxidation number changes 0 to 2 plus, and for copper it is plus 2 to 0, right? So copper it is plus 2 to 0. Now see, for zinc the oxidation number is increasing, so it is oxidation. For copper the oxidation number is decreasing, so it is reduction, right? So this is the reaction. This type of reaction is called as redox reaction, and since Zn is undergoing oxidation, it is a reducing agent, and since copper is undergoing reduction, it is an oxidizing agent. Okay. Now we understood what is oxidation number. Let's how to calculate the oxidation number. There are certain ions whose oxidation number you should be knowing. Oxidation number of an element in the pure form is always 0. For example, you see carbon, zinc, copper, oxygen, H2, O2, they are in the pure form. Their oxidation number is considered to be 0. Next you have oxygen of an atom in a monoatomic ion is equal to the charge of the ion. So if you have a monoatomic ion, for example, if I have Zn2+, if I have Mn2+, if I have Cl minus, if you have S2 minus, O2 minus. So these all are monoatomic ion. So whatever is the charge of the ion, the same is the oxidation number of that element. Okay. Now here we have certain elements. Oxidation of fluorine is generally -1. For alkali metals means group 1 it is +1, for group 2 it is +2, for oxygen it is -2, in case of peroxides it is -1, superoxides -half, and for H it is +1, and for metal hydrides it is -1. Now let me take you an example. For example, KMnO4. Calculate the oxidation number of manganese. How will you do? See, K potassium, right? It is a group 1 element. For group 1 element the oxidation number is 1. Next, manganese I want to calculate. Let it be X, unknown value. Oxygen, in general it is -2. For each oxygen there are 4 oxygen here, so 4 into -2. Okay, so what I will get here? 1 plus X minus 8. Now what is the net charge of this compound? The net charge of this compound is 0. There is no charge in this compound. So what will be the value? If I calculate X, it will be +7, right? So the oxidation state of manganese is +7. Okay. Next, let's try for another compound, CO3 2-. Okay. See, carbon here we have to suppose find for carbon. Let it be X. Oxygen is -2, so 3 into -2. So I can write -2 into 3. Now here the net charge is -2. Okay, here I was equating it to 0, but here the net charge is -2, so you have to equate it to -2. So what I will get here? X minus 6 is equal to -2, X will be equal to +4, right? Next we have something, let me give you one more example here. Can we do for, okay, let's try for doing ClF3. Okay, very simple. Or let me just change another one, just a minute. Let's do for NH3. Yeah, very simple. You have to calculate for nitrogen. Nitrogen is X, hydrogen charge is 1, right? For 1 hydrogen. For 3 hydrogen it will be 3, and here since the net charge is 0, so that is equal to 0. So X will be equal to -3. Okay, so that is how you can calculate the oxidation number of various elements in a compound. Clear? Okay. Now we will move forward to this logarithms and graph. This is very, very important. In one chapter you have to use again and again. So first we will know some important formula of logarithm. So one is log of, okay, no, sorry, just a minute. I can just write like this. See, a to the power of x is equal to x log a. This is the first thing that you should be knowing. Okay, a to the power of x is equal to x log a. So if I just write like this, 2 to the power of 5, okay, or I can just 2 to the power of, yeah, suppose I write log a to the power of x. Yes, so if I write log of 2 to the power of 5, that means 5 log 2. Okay, clear this one, the first formula. So that is the general formula of log. Next thing that you should be knowing is log of a dot b. Means if two numbers are in multiplication, its log, when you expand it, it will become log a plus log b. Okay. Next, if you have log A by B, then it will be log A minus log B. Okay, here is the difference. Okay, next I have and one more you think you should be knowing, log 10 value is taken as 1. Okay, log 10 value is 1. This is all you should be knowing. Now we will tell you ln to log. So generally, if, as I said, log of a to the power of x is x log a. Similarly, there is another exponential term, that is e to the power of x. Okay, if you take ln of e to the power of x, that is x ln e. Okay, now if I want to convert this one to log term, okay, so what you have to do to convert this ln, so you should remember ln is equal to 2.303 log. Okay, so if I just want to convert this ln e to log 10, okay, if the base for this one is e and for log the base is 10, so this is like log 10, this is ln e. So if I just want to convert this ln e to log 10, I can write x 2.303 log 10. Not like this, base, I should write it as base. Okay, so whenever you have to convert ln to log, you have to multiply that with 2.303. Okay, this conversion is also very important. Now moving to the graph. Okay, so here we need one single graph, that is y is equal to mx plus c, this straight line equation you should know. So whichever graph you have to design, you have to write that equation in this form. Here y will be your y axis, this one. Okay, this is your x axis, the slope here is m and the intercept is c. Now this is a positive slope, right? You can see, so it has to be in this way. Okay, where this one is your c and this value is your m. So whatever graph is given to you, whatever question is given to you, you have, suppose for example, I'll give you an equation. Let's try this one. So this is, just a minute. One second. Yeah. So this is directly from class 12. I'm giving you one equation. Suppose you have a term like this, log kt is equal to, kt equal to 2.303 log of a naught by a. Okay, this is an equation given to you, and I want you to plot a graph for log a naught by a versus t. You have to draw this graph. Okay, so how will you do? So this is a practice. You have to first identify this is your y, whichever is given first, that is your y, and the other one is your x. So arrange this equation and write it in the form of y equal to mx plus c. So if I arrange, y means this one, so I will keep these term and I'll take all other terms to the other side. So I can write it like this, log of a naught by a is equal to, this 2.303 is divided here, k by into t. Okay, so what will this one give me? You can see this is y, this is m, and this x, and this is c, and this c here has no value, means it is 0. So whenever c is 0, the graph has to start from the origin. So now I can draw this graph. What is my y here? Log of a naught by a. Okay, next I have slope. Slope will be like this, and what's the value of slope? K by 2.303. Okay, and the intercept here will definitely be 0. Okay, and what is x here? X is equal to time. Clear? Okay, fine. Now we can go back here to the graph part. So with this, physical chemistry most important concepts we have already covered. Now we will talk about the concepts from inorganic chemistry. So what all concepts I have in inorganic chemistry? First is basic inorganic chemistry, periodic table and chemical bonding. So in basic inorganic chemistry, first thing you should be knowing is quantum numbers. Now quantum numbers, what are they? Quantum numbers are something that will tell you to tell the position of the electrons. Position of electrons. Okay, there are four, basically there are four quantum numbers. What are they? The first one is principal. Okay, next we have azimuthal, next we have magnetic, and then we have spin. Okay, now here how can we designate it? Principal quantum number, as I can write it as n. Okay, azimuthal quantum number L, magnetic quantum number ml, spin quantum number ms. Okay, these four quantum numbers are there. Now principal quantum number values can start from 1, okay, to infinity. Okay, you can have 1, 2, 3, 4 till infinity. And azimuthal quantum numbers value will be from 0 to n minus 1. Okay, I will explain this in detail. For now, just note down this one. Azimuthal quantum number will be from 0 to n minus 1. Magnetic quantum numbers will be from minus L to plus L. Okay, what is this L? This azimuthal quantum number. Okay, we'll discuss it in detail. And spin quantum number will always be plus minus half here. Okay, now let's take one example. Suppose I have principal quantum number as 4. Okay, what all azimuthal quantum numbers are possible? Azimuthal quantum numbers values are 0 to n minus 1. So 4 minus 1, 3. So 0 to 3. So I have 0, 1, 2 and 3. Now what is azimuthal quantum number values? It will change from minus L to plus L. Now see, 0 will not have minus 0 to plus 0, right? So there will be only 1 ml value. Here I will have what? Here I will have minus 1 to plus 1. So minus 1, 0, plus 1. Okay. So this one will be 0 only. Okay. Next I will have here minus 2, minus 1, 0, plus 1 and plus 2. Here I will have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Right. Now with these numbers you can, some letters are also assigned. So for 0 we write S, for 1 we write P, for D and then F. So this is what? This is your 4S. Okay. So ml value is 1. So in 4S we have only one box. Okay. Next this is 4P, and in 4P I will have 3 boxes. So this will be 4P. I will have minus 1, 0 and plus 1. Okay, so this is what, see, this is called as shell. Okay, this is called as subshell. Okay, and this is called as orbitals. Okay, so this whole thing is called as subshell, and inside these 3 boxes, these are your orbitals. Now we have D. In D I have 1, 2, 3, 4, 5. It is 4D. And here I will have minus 2, minus 1, 0, plus 1 and plus 2. Then I have 4F. I have 1, 2, 3, 4, 5, 6, 7, 4F. Here I have minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Okay, so you can see here I have 7 orbitals, here I have 5 orbitals, here I have 3 orbitals, and here I have only 1 orbital. So these all things will be required to write the electronic configuration. So let's see that. So there are certain rules for writing the electronic configuration. The first one is your Aufbau principle, which says that in the ground state of the atoms, the orbitals are filled in the order of their increasing energy. So what is the increasing energy? First we have to fill 1s, then 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s. So this order you have to maintain. You have to fill that in this order. And what is this energy? This order is the energy of the different orbitals. Okay, now here I'll tell how to calculate the energy of the orbital. You have to follow L plus S. Okay, so you have to add the sorry, not L plus S, N plus L. Please note down this one. Energy of the orbital or energy is calculated by N plus L rule. Okay, you have to add the quantum number and the azimuthal quantum number. Okay, so for example, I have 3s and 3p. Okay, what is N plus L here? 3 is N, this is S, S means it is 0, and here I have 3 plus 1. So this is 3 and this is 4. So definitely this value is more. So its energy will be more than 3s. So you can see here, after 3s, 3p will come. Means 3s is the lower energy one. So it has to be filled first. Then you have to fill 3p orbital. Okay. Next, what I have here is, suppose this one is I have 3d and 4s. Here I have N plus L, 3 plus 2, and here I have 4 plus 0. Here it is having more energy, here it is having less energy. So first this one will be filled, then this one will be filled. Okay, so you can see that after 3p, 3d doesn't come, 4s comes, and then 3d comes. Okay. Next rule is Pauli's exclusion principle. No two electrons in an atom can have the same quantum number. So always if you are filling the atoms in one orbital, you have to do like this. One represents plus half spin and the other represents minus half spin. Next we have Hund's rule of maximum multiplicity. Here it says that electrons in the orbital belonging to the same subshell does not take place until each orbital belonging to that subshell has got one electron each, that is, it is singly occupied. So I have already told you S will have one orbital, P will have 3 orbital, D will have 5 orbital, and F will have 7 orbital. Now when you fill the electrons, you should start giving one electron to all of them, and then the pairing should start. I'll explain with an example, it will be more clear. So let us start with one example. For example, sodium. Okay, sodium has atomic number is 11. So what all orbitals I have? See, I have 1s, I have 2s, then I have 2p. From where I am getting this order? From this one. From here I am getting 1s, 2s, then 2p, and then I will have 3s. Okay, so in 2p, since there are 3 orbitals in p, so I am doing 3 here. Since there is always one orbital in s, so I am doing 1 boxes here. Now if I want 11 electrons, so first it will have 2 electrons with opposite spin, 1, 2, then 3, 4. Now when you fill this, you have to fill one electron to each orbital first. That is what was the last rule that was given to you, that is Hund's rule of multiplicity. Okay, you have to give one electron to each orbital first. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then I will have 11 here. Clear? So like this you can practice for different elements how to write the electronic configuration. Next, one more if I want to give you for let it be nitrogen, simple one, 7. Okay, so first I will have 1s, then I will have 2s, then I will have 2p. Okay, so I will have 1, 2, 3, 4, 5, 6 and 7. Clear? So that is how you have to write the electronic configuration. Next thing which I am going to tell about is, this is not there, yes, periodic table, about some trends you should be knowing. So atomic size, what happens along the period, all of you should be knowing this one, along the period it decreases, and down the group, okay, it increases. You can see here, down the group it is increasing, along the period it is decreasing. Next is ionization enthalpy. So what is ionization enthalpy? The energy that is required to remove one electron from the valence cell. To remove one electron, how much energy is required? That is called as your ionization energy. Now ionization energy, what is there? The order along the period, you should be remembering this one, or you should be knowing this one. Along the period it increases, down the group it decreases. Along the period increases and down the group decreases. Next we have electron gain enthalpy, the tendency to gain electron or the energy that is released, or when the electron gain enthalpy is the energy that is released when one electron is added here. Now here what happens? Along the period increases and down the group decreases. Okay, same as ionization enthalpy. Next, we have a concept of hybridization. This is from your chemical bonding chapter. So, what do you mean by hybridization? Hybridization is very simple concept. Different atomic orbitals, okay, different atomic orbitals mix with each other to form hybrid orbitals. Here you should know that number of hybrid orbitals formed, is always equal to number of atomic orbitals combined. Okay, number of hybrid orbitals formed is always equal to number of atomic orbitals combined. For example, if I have S1s and p orbitals are combined, then I will get what? sp3. So I will get 4 sp3 hybrid orbitals, sp3, 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 sp3. Here I am telling you to remember certain important hybridizations. One is your sp3 hybridization, another is dsp2 hybridization, and sp3d2 hybridization. This one is tetrahedral, the geometry. This is square planar geometry, and this is your octahedral geometry. This will be required in the class 12 chapters. These 4 hybridizations, these 3 hybridizations will be required much more. So do practice this one once again. Okay. So here how many hybrid orbitals will form? 4. Here also see 1d, 1s and 2p. So here also 4 hybrid orbitals will form. Here if you see 1s, 3p and 2d. So here we will have 6 hybrid orbitals. Clear? Okay, so yes students, that's all in this video. Please be waited for part 2 where we will be revising the organic chemistry completely. And if you have any doubt in these concepts, do comment down. I'll definitely answer to them. And please subscribe the channel. Please join this series if you are serious about your preparation for KCET 2026, as we are going to provide everything that is required for your top rank. Okay, so you have seen the last year results. You can even contact your seniors. Those students, if you know them, they will definitely tell you about this series. So please subscribe the channel and do not forget to join the WhatsApp channel. All the very best, keep learning, and all the best, and see you soon in the next class.